Okay, there we go. So we've been working with bath bombs. We've been doing this for quite a while now, about 3-4 weeks. And we determined through a series of investigations that the gas was not trapped inside of a bath bomb. It wasn't all the little air pockets that as the bath bomb dissolved in the solvent, which is water, that the little air pockets didn't let the air escape, causing bubbles. We tested each individual ingredient by itself. And then we came back and we found that citric acid and baking soda, whether it was mixed in the lemonade or whether it was just citric acid by itself, was the main cause for the gas. So it's a gas production. We are creating something that was not there previously. Hopefully we're all kind of understanding that. We're kind of all on the same page with that. Nothing too shocking in this kind of discovery, correct? Does anybody have any questions about what I've just gone over so far? All that was pretty self-explanatory. Merrick, yes, sir.
So we're just trying to determine what gas it is, right?
Well, the first half of this was we were trying to determine where the gas was coming from. And that's where I kind of stopped right there. We were able to determine by a process of elimination from one, testing each individual substance that was made in the bath bombs. You know, we tried each one of them with water to see if there would be any kind of reaction. And we saw things like some of the products dissolved, some of them didn't dissolve, some of them separated, some of them were more dense or less dense, you know, but nothing produced gas by itself. There was a little misconception every once in a while. Somebody thought they might have saw some air bubbles, but just because you see some air bubbles does not mean you're having a production of gas. I mean, you have to see a generation of gas, not just a couple of air bubbles floating in something. So then we did an experiment last week where we were looking at the density of the gas. We saw that when we had the reaction in a flask, that it would put out a flame above the flask, but we soon realized that was because we were creating so much gas in the flask that it was escaping. You know, it was pushing the gas up out of the flask. I don't have any flasks around me right now, but we quickly determined that when I poured the gas into a container, the gas would settle into the container and put out a flame. So we determined that the gas was more dense than the air around it. It was heavier. More dense is the proper term, but you know, we could also add that as being more dense. Does that make sense to everybody? Anybody have any questions on that? Okay, so no questions. This is good. So I gave you a chart where you had the common gases found in air. Some were more dense than others. Some were lighter than air. Some were more dense. And we were able to determine that, I mean, there were only 5 gases that were more dense than air: nitrogen, oxygen, argon, propane, and carbon dioxide. Now, Buvia, how you doing today?
Good, how are you?
I'm doing very well. Buvia, one of the gases we eliminated from that list of 5 gases was propane. Any idea why we eliminated propane from that list?
Yes, because propane was flammable and the flame went out whenever the reaction happened.
Right. And I mean, not only is it flammable, it's explosive. Propane is something we cook with, so that flame would definitely not have burned out if it was propane. Lauren.
Yes, sir.
So another gas we eliminated was oxygen. Why did we eliminate oxygen?
Because it caused the flame to get bigger. It didn't extinguish it.
Right. So if it was oxygen, it would make the flame get bigger. So that leaves us down to 3 gases, and that's kind of where we're at right now. But we're going to look at these very quickly to make the final determination, which I have to say the majority of us already know what the gas is. But I just want to eliminate these by logic. So, Rachel, how you doing, sir?
Good.
So, Rachel, one of the gases, so we have nitrogen, argon, and carbon dioxide left. Why do you think or don't think could it possibly be nitrogen?
Probably not, because that's probably not cool. But I'm opening up the chart right now.
Okay.
To see what the stuff is. Okay. Nitrogen.
And that's the only one I want us to talk about is nitrogen.
I don't think it could be a nitrogen because it shows less dense, I think.
Okay.
Is it?
Well,
Is it less dense?
It's less dense, and we know this gas was less dense. But there's a very specific reason why we could eliminate nitrogen off the list. And if you're not sure, that's okay.
I'm not that sure.
All right, let me, Merrick's sitting there patiently with his hand up. Yes, Merrick?
Didn't it try to say that it made up 70-something% of air?
78%.
So if there's already that much in the air, the flame should just go out.
Right. We already have such a large percentage of nitrogen in our atmosphere. So by producing just a little bit more, it really shouldn't put it out. We're still talking that we're already dealing with so much nitrogen in our air. Maybe if we removed all the oxygen out of our air, but we're not doing that. We're just adding a gas to it. So, Jay, are you still with us? Yeah, there you are. Okay, you moved around on my screen a little bit, Jay. You there, Jay?
Yeah.
Now, this one's going to be a little bit more tricky, but argon. Do you think argon could have possibly been the gas that is produced? Why or why not?
Wait, can you say the question again?
Argon. So we've already, nitrogen was not one of the gases that was produced because we're down to nitrogen, argon, and carbon dioxide. We've eliminated nitrogen because we already know there's so much nitrogen in our atmosphere that shouldn't have caused the flame to go out.
Okay.
Argon. Do you think possibly it could have been argon? Why or why not?
Let me check the chart. I don't think it can be argon.
Why? Just a feeling?
Yeah.
Okay. Does anybody know anything about argon?
Mr. Schillinger, can I add to this?
Yes, Lexi.
So doesn't argon make up 1% of like the atmosphere?
It does.
So I think that could be something like it's already like a small part of it is in the atmosphere, and then I think just from seeing the chat, like it extinguishes a flame
Okay. Well, now
too. But
one thing when we're talking about 1%, that's a very low percentage, and some of these other gases are also low percentages. But the thing is, and this is the trick. This is what you guys probably don't really know yet. I mentioned it in passing. It's a noble gas. Does anybody know what a noble gas is? Nope. A noble gas on a periodic table is all the way over on the right-hand side of the periodic table. They don't join with any other element. They're always by themselves. So, are we producing a gas? We're creating a gas, right? So that has to be in the chemical formula of the bath bomb somewhere. So we're rearranging atoms. We're taking atoms and we're changing them around. Argon doesn't join with anything. So argon is not in the bath bomb anywhere. And we can't just create something, right? So argon we eliminate by the process of elimination. That argon is not part of citric acid. Argon is not part of baking soda. It's not the formula that makes up those. You'll never find a noble gas mixed with anything else. That's kind of the trick question right there. That was something that was kind of hidden in there. So hello, Clara. I see you just popped in here. You may have came in and left. You there, Clara? Okay. Vaishnavi,
Yes.
how are you?
Good.
Good to hear this.
I also don't want to answer that. You'll ask me a question.
What's that?
I don't want to answer that question.
The question about how are you?
Yep. Then you'll ask me another question.
I am going to ask you another question. So, by process of elimination, what gas do we have?
Well,
What gas is being produced by the reaction of citric acid in?
we have carbon dioxide left.
Yep, carbon dioxide.
Is that it?
That is it.
We had another one.
There shouldn't have been another one. We eliminated oxygen, propane, nitrogen, and argon. The only one that was more dense was carbon dioxide.
Okay.
Which other one do you have?
I'm not sure.
Let me double check my chart real quick. Nitrogen, oxygen, argon, carbon dioxide, and propane. Yeah, those are the only ones that I had that were more dense than the air. Okay. So by process of elimination, it was carbon dioxide. Now, we're going to find that carbon dioxide is actually a byproduct a lot of times in a reaction when a gas is produced. Carbon and oxygen bond together like crazy. And one of the reasons why is our planet, all the things living on our planet are dependent on carbon dioxide. Are we dependent on carbon dioxide? Merrick's over there shaking his head no. Shrey, are we dependent on carbon dioxide, yes or no?
No.
So, If I eliminated all the carbon dioxide on this planet right now, how would the plants make oxygen?
They wouldn't, so we'd all die out. So yes, we do need carbon dioxide to live, but not directly.
Yeah, we don't need it directly.
No, but we need it. We're dependent on it. If we don't have it, the things that make our oxygen are gone. And therefore we die. So yeah, it's not a direct, but we are dependent on it. I mean, I'm not dependent on cattle feed or chicken feed, but I'm a meat eater, so I'm not dependent on the food that is given to chickens and stuff like that, but I definitely need it for for me to get my protein. That's a stretch of imagination. Forget that. All right, so here's what I'm going to have you do. I am going to, in just a second, post 2 videos. Make sure you watch part 1 first and then part 2. These are videos on what is called elephant toothpaste. It is a hydrogen peroxide, potassium iodide reaction. If you've ever seen a video of elephant toothpaste, it creates a lot of foam. Some people have it and it just shoots all the way up to the ceiling. It's kind of fun, thing to do. But I'm going to want you to watch both those videos, and then there is going to be an assessment that you're going to take based on watching those videos. And if you need to, go back and watch the videos as many times as you can. All right? Each video is only about 1.5 minutes long. Any questions before I give you the assessment? You're basically going to do the same thing that we did with discovering of the carbon dioxide. You're going to use the evidence provided to determine what kind of gas is being produced in this reaction. Now, ladies and gentlemen, I know you can Google the answers, but just getting the answer is not going to give you the correct or the grade you need on your test. You must provide evidence based on the videos. Okay? Merrick.
Can we use a chart?
Yes, you may. All right. I will have my Google Meet open. I actually have to load up the test right now. It's not loaded yet, so it's going to take me a second. You can leave the Meet to take the test if you wish, or you can stay on the Meet if you have any questions. Fair enough? Okay, with that being said, give me a second. Let me go ahead and get this going real quick.
When is it?
Say again?
Excuse me, Mr. Schillinger, when is it due?
It is due by the end of the period.
Okay.
It is so hard to believe it is week 13 of school. All right. Sorry, I was late getting to class, so I didn't have a chance to have all this ready just to submit. My apologies to you. I'm sure you guys are probably used to this by now with me. Oh, really? It froze up on me. Stop. Am I the only one that ever talks to myself?
No, I think everybody does it sometimes.
I just hate it that I get into an argument and I lose. Actually, maybe if I stop recording, I don't need to be recording at this point.